So, as already mentioned, my name is also Vaclav. I'm staff software engineer at SentinelOne, concretely in one of the security services team. And we are working in Kotlin and in Spring Boot and any other like libraries and so on, but Kotlin is the main, right? And today I would like to share some like experience with a cluster scheduler called DB Scheduler. It's a like free project, and yeah, let's do it. So agenda is really short because it will be more about coding and not about theory right now. But start with some motivation. Why do we actually need a clustered scheduler in our team? And then let's go through some like set of requirements we had for the clustered scheduler, and then finally continue with some demo and tips. And the last part is for you. It's questions. First of all, it's not only a couple of us here, so feel free to interrupt me, ask during the presentation. It's up to you. So motivation. Why do we need a clustered scheduler? I would say that it's probably like the same for all of us, but as already mentioned, SentinelOne is a cybersecurity company providing protection of many surfaces, and beside this, it also like offers some security services, and Vigilance Services is one of them. It's MDR, Managed Detection and Response, and basically what it means is that in case you will be our customer, set of threat analysts and threat hunters will like protect you non-stop. And I and my team, we are building some internal applications and tools for the like team of analysts and threat hunters. And basically we are aggregating and consuming and handling all threats for all our customers around the world. And because we are in like cybersecurity domain, resiliency, high availability, high throughput are super crucial for us. So basically, how we use scheduled tasks, we have like two primary like use cases for it. One is as an alternative to queues somewhere. Very suitable, for example, when we are waiting for some data, for some like external resources, we need to pause some like data pipeline, wait for a while, and then continue, trigger another part of the pipelines, and so on and so on. It's super useful here. And the second case is as a compensation workers for any like failed states, for any retries, for data reconciliation mechanisms, and so on and so on. So requirements. We realized that we want to go with some like clustered scheduler about half a year before when we started with a new version of the software we are building, and we defined some set of requirements. So let's check it. And the first one is obvious. We wanted to start some task only on single Kubernetes spot in our replica sets. It's important for us. We want to keep the application like easy to read. We don't want to like implement any DB logs on our like living tables, living columns, and so on. So this is something what keep us really simple to monitor it, to observe what's going on, and so on. We want like the state management of the DBs of the scheduler, cluster scheduler over database. Why? Because it's super simple for us. In case of any issues, we are just connecting to our existing database. We can like unblock it. We can check what's going on there. So the DB state is something really nice for us. We want simple lightweight solution, so definitely not Quartz. And ideally, we want some like native or out-of-the-box Spring Boot integration, which means some starter, auto configurations, and so on and so on. As a benefit here, it would be integration with micrometer metrics, because we are building like a lot of dashboards around it. And probably the most crucial requirement for us was like active monitoring of running task. Basically, that means that we must be 100% sure that new execution will never be triggered in case there is still some active execution. And it's because that under some like circumstances when there is some higher load and so on, some of the jobs could take more time than expected. In that case, we must be really 100% sure that no other execution will check the data, will transform some data for us, and so on. So this was really something what we are looking for, and it was quite like short time to look for something, because we quite immediately find a DB schedule project. It's open source, is available on GitHub, and on this page there is like all the documentation you will need for like standalone project, for Spring Boot integration, a couple of examples and so on. So really awesome. Okay, any questions for the theory, or we can go to coding?
Do you know Chalupa?
I know Chalupa, and exactly the last point is the reason why we are not using it. Actually, author of Chalupa is working in Sentinel-1 right now. But Chalupa, exactly, there is only like defined timeouts, but no active monitoring of the task. So let's try some simple project with this. Okay, so I have some really simple Spring Boot project, nothing there actually. And the first thing, actually, there is this demo service, and this is some service we want to call from some scheduled tasks. So when you want to start with a DB schedule project, the first thing you need to do is to add dependency for it, and that's basically all. It will like auto-confer out of the box. You can use it without like any changes. And because it's DB scheduler and the state is synchronized over like database table, you also need to prepare some like database table. So I have this like flyaway migration. Again, this is something what you don't need to like define yourself. It's defined in the documentation for all available databases and so on. So just copy paste it to your migrations and you are done. Okay, I need Docker. It's probably killed as well. So give me a second. Yeah, so how to define scheduled tasks? So it's defined as beans. So I will convert this to configuration class. And one of the best practice we have is to make all the schedulers you will have conditional, because right now, for example, we were like able to disable some like malfunction scheduler in production, fix it, and then restart again. So let's do it here as well.
But don't you have to restart the app for that to take effect anyway?
Sorry?
You still have to restart the app, right?
Yeah. But it's about like editing environment variable in Kubernetes, and that's all. Okay, and let's define the first scheduled task. Let's use or inject the demo service, and use the task from the DB schedule project. Right now, you can define like one-time task meaning start take only once, but we never use it. We are using always the recurring or repeated task. You need to define some name for it. And this name is then used in logs. It's used in the database table to identify the task, and it is used also in metrics. Then you need some like trigger for it. Let's start with fixed delay. Let's say that we want to start it each 10 seconds. And we can execute something. And to actually see that something has happened, let's use some logging. And let's call the demo service here. Okay, so let's try it. Okay, you can see that the first task is executed as soon as possible, even before the web interface of the application is ready, and the other execution will follow as defined. Okay, it's there. So right now we have a really simple task, but we never use the fixed delay because it means that the next execution will start 10 seconds after the preview is finished. And we usually want some regular execution, something what we are expecting and so on. And also it's quite hard to configure these things. And exactly for this, DB scheduler provides you some cron scheduler with cron expression. Again, some best practice for us is to define some configuration properties.
Can I ask a question? So you mentioned it never spins up a new execution unless the task that's being currently executed has finished, right? So if that demo service process took longer than 10 seconds, it would never trigger.
Yeah, this is the fixed delay as before. It will always wait 10 seconds after the last finish.
Okay, so it'll execute no matter what?
Yes.
Okay.
And let's use it here. Okay, and last thing here, what we need to do is actually define some default value for the cron expression. And let's again start it each 10 seconds. Okay, should be all. So let's try it. And again, it won't be started exactly each 10 seconds, but it will use some point in time, and then each other 10 seconds. So yeah, so the first execution here, 50. Yep, 0 here.
And so this will run even if the last run hasn't finished yet?
No,
it'll wait.
It's part of another demonstration. Let's try this with multiple running instances. So I will start second instance of the application, so sharing the same name of the scheduled task. And we should see that only like one or single instance is actually executing the task. It will be probably the first one. Yep, so it's running there and silent here. And so it's working as expected. Okay, so absolutely no configuration, just adding dependency and simple like bin definition, that's all, and you are up and running. Let's try to change this to like each 15 seconds. It should be like the same, right? So let's try it. Because this is something what you would probably do, maybe you will need to change it like in production without like any like code changes and so on. So let's see what will happen.
First one is still running.
Oh, it is? Okay, sorry. So restart this. Is that? It is. Okay. So at least you can see that like the task was like executed on the second instance immediately. Okay, I will just clean up the database just to be sure and try with like 15 seconds. Okay. Right. It is there. Oh, I can see it here. It's there. Great. So, first execution 08. And now you can see it. It's not 15 seconds, it's 10 seconds. Like 08, 18. What else? Oh, 38. It's not 15. It's 20 seconds. What's going on? So right now you start panic, and you will probably check documentation, and that's the good step, because you will find some configuration for the DB schedule called polling interval. And the default value for polling interval is 10 seconds. This is the interval the DB schedule background processes are checking the database state. And because it's like 10 seconds and you have 15 seconds schedule, it's never this like matching the time. That's the reason, because DB scheduler is quite smart. It still tries to check the best suitable time. So in average, you are on 15 seconds, 10 seconds, 20 seconds, 10 seconds, 20 seconds. It will do that way, but it's probably not what you expect. So let's try to use 5 seconds polling interval right now, and let's see whether it will behave better. Yeah, so the first execution and 19 should be the next one. Yep, it's there. So great. Solved. Okay, and now what if the function you are calling, the procedure I'm calling, takes more time than the 15 seconds. So what will happen? As mentioned, we must be 100% sure that new execution won't start. So let's add some sleep there, and let's check what will happen. And we can start both instances to see it in the clustered, semi-clustered environment. So we can see that first execution started here, and it's already 15 seconds, nothing happened. It's still waiting for the current task to finish. Nothing on the second instance of the application. So let's wait for task to finish. End it right now, and after the successful finish, the next execution is started somewhere. Yeah, the same. Okay, so because we have already something like log running, we can also check the database, how it looks like there. And this is the structure of the table. You can see that here is registered the task we define, the type of the task, and the picked means whether the task is currently executing by some instance or not. Let's try to observe it for a while. And right now we should be able to see that the picked is changing when the task is running or not. Last success is there, last heartbeat. Let's go back to this after a while. How long the execution took, some internal identification of the instance, and last failure timestamp in case of any failure of the task. So great, it's working. And let's move to some example with that execution detection. So right now we have some long-running task, and it could fail in time because the power could be switched off and the instance is dead without any notify that the task actually died. So I need to stop this. Okay, and go to services. Okay, so here is running task, and I can kill it. So right now in the database, the task is still there as picked, and with some last heartbeat. And right now, I would expect that the DB scheduler is able to recognize that execution as soon as possible. Because I don't want you to wait for it. It won't happen in next 30 minutes. And this is another time you will probably panic what's going on, because in case you have such a rapid task, each 15 seconds, and you will wait half an hour, you miss more than 100 executions. So what's going on there? And again, it's part of the configuration. You will find another configuration called heartbeat interval, and here is the tricky thing. The default value here is 5 minutes. So it provides a heartbeat at the beginning of the execution, and then it waits 5 minutes for another heartbeat. It's quite a long wait, but it's not it's not everything, because there is some internal threshold, and the heartbeat interval must be exceeded 6 times to actually detect the execution, and it's half an hour. And as mentioned, this is quite a lot for any rapid tasks. So let's try to change it to 5 seconds again. and we can also observe in database that the heartbeat is changing. Okay, so I will call this as well. I want to restart it just to be sure it's okay. And let's start both instances. Okay. And again, just check this one. Let's put false. So the task is running, and let's check the heartbeat column here. Should be changing each 5 seconds. Yeah, it is. So great, we have finally some like rapid detection probably configured. So where is the task running? I have to stop this. 16. Okay, let's wait for another run.
So maybe a question. So if you have, you can have multiple instances. What configuration?
Sorry. Right now I will kill the running job, right? And let's wait. How long will it take now to detect the job and start execution on the first instance? And as you can see it, it's there already handled by the first, by the other instance. And you will also find some information in logs that there is some found that execution and that it's like handed over by this instance. And just check the times. So I stopped it. It was around 41:00. So it took like 40 seconds right now to execute task on the second instance. So it's really nice right now. Okay, so I will start everything, and the another like topic I would like to share is like the set of metrics provided by DB Scheduler. So I will slightly update the demo service to fail sometimes in the half of the cases. Just 5 seconds. One-time exception. Okay. So I just want to wait for 5 seconds for half of the executions and throw exception or fail for the other half. Already stopped. Yeah. So right now we'll start it again, and let's check the logs. The first thing you will notice is that the failed execution are like handled by the DB scheduler. It's logged. The default level is warning, but you can also configure this to error, for example, to debug or anything you want. And the other execution is started as usual, so no errors there are affecting the scheduling. So we have already some executions there, so let's check some metrics. Okay, it's there. So there is some like default set of metrics provided out of the box. One, for example, is like the total number of completions, and you can also see there is some tags already prepared with the result, whether failed or OK, which means success, or with the numbers. There is also the maximum duration of the execution. There is also information about like summary time here, so you can use it to show you some average time of the executions and so on. Everything out of the box, so nothing needed to do from your side and prepare like any own metrics just for the scheduling. Let's try to refresh this. Yes, we can see that the numbers are changing. We can also see that we have like 3 successful execution. It is matching with a 15 seconds like total execution time and so on. So like pretty nice. Not found why. Okay, give me a second. I just want to show you. Yep. So for example, this is one of like our graph from some testing environment. We have set like dashboards for each scheduler when we are checking that everything is executing as expected, and you can then simply set like any alerts or PagerDuty like escalation when you missed a couple of windows, for example. So that's still like everything is prepared for you. Really great. Okay, so let's stop it. Last but definitely not least feature of DB scheduler I would like to show you is some integration with some scheduling context. So I will prepare another like function here, but I would like to I would like to get their scheduler state, and here we can simply observe whether we are like in graceful shutdown period or not. Okay, that's fine, that's better. So, and let's check for the state here. If shutting down, return. Sorry, one more. So let's do that way. Times 10, for example. Okay. Shutting down. Repeat. And so basically I want to wait like 20 seconds. So it's some example of like a long-running task, but with some batching, for example. So you are loading a couple of batches from database and executing something and so on. And you want to support required shutdown. So right now I'm like monitoring the scheduler state, and in case it's shutting down, I will just skip the executions. That's all. What you need to do here is to use some like context here, and the context part of the context is the scheduler state, and that's basically all you need to do. Okay, let's start it again. Okay, we can see that like the task is running. There is no shutting down. I will wait for this like 20 seconds just to confirm it's working as expected. Yep, ended. Like it's not shutting down. Started a new execution, and let's request like shutdown. Yep, and you can see that where is it? Here. Also, information here is that by default it will try to wait like almost 1 minute to finish the execution, but in case you will support this like graceful shutdown, it will shut down immediately or as soon as possible as you implement it. So again, pretty nice. So and the last note or last tip I would like to share with you is about testing. So definitely you can test it also. You can test the scheduled task you have in the application, but probably the first thing you would like to do for your integration test is completely disable all scheduled tasks, because otherwise it will run randomly during your test execution. It will like change your data and it will fail randomly. So this is like our configuration for tests, and in case we want to test something related to schedulers, we also we enable it just for the test. Okay, so probably something like that. Let's try to run the test just to be sure I finished. It's stopped. Yep, it's working. But you probably don't want to wait like 9 seconds in your test, and you probably don't want to wait 1 hour for one hour scheduled task. So of course we are like modifying the cron expression to something like that, and also it's quite good idea to set a polling interval for 1 second. And right now the execution should be really fast. Yep. So under 1 second. So yeah, that's all. So questions, if any? Yes.
Compatibility with Spring. I know I've seen like upgrading the version of Spring Boot can mess things up. I guess you have only started using it recently, so you haven't seen any like issues with transitioning to
No issues with the DB scheduler. Recently we updated from version 2 to 3.1 or 3.2, and a couple of weeks back we upgraded to 3.3, and no issues. Actually, the only issue we are facing is with the change with observability libraries in Spring. So in case you want any like tracing there, it was previously with the version 2, it was out of the box. But right now you have to like wrap the execution with some like initialization with the observability context to set the trace ID, for example, span ID and so on, and it was a little bit tricky. That's the only way, that's the only thing, but otherwise the upgrades are really smooth. The library is currently reacting to any changes really fast, so it's great.
You have some production environment, like configuration recommendations, because you're running it at scale, right? And you're talking about the polling interval and the heartbeat. Is your go-to?
Nothing else changed except these two configuration properties. and half in a year in production, no issues.
And the typical polling interval for you is like 1 second, because 1 second seems like quite a lot.
Yeah, actually, I don't see any reason why not to have 1 second, because we are bombarding the database like each microseconds, and this one like 1 second execution is okay. But for the polling interval, we have the default. We have 10 seconds right now, because we have timers like each minute, each 10 seconds, each 30 seconds. So we keep the default right now.
Is it possible to use also some NoSQL database for storing that tasks table?
Oh, good question. I don't know. So let's check what's there. MariaDB, MySQL, Oracle, Postgres. I'm afraid not, because do you know why not? Because it's based on locking, probably, and on some like transaction state. So I believe that the implementation on conditional updates is okay as well, but I don't think it's implemented. But what's there? I don't know. And actually, when I prepared this demo, I firstly found it because I was like waiting for the like handover to the second instance, and it's not coming, and it's hard coded in the implementation. It's not mentioned in documentation. That's the first issue, and I'm not sure whether we are able to like configure this. Maybe yes. In case you could like debug this, probably somehow like inject there and check it. But in case you will like set the heartbeat interval to 1 second, the like detection is within like 10 seconds and you are ready to go.
You said in the beginning you will mention some reason why you are not using that other tool.
We are not actually. So what we know, we are considering the Shadlog, but there is no active task monitoring, and we also know the Quartz, but I don't want to have dozens of tables and something bigger than our application just because of scheduling. So it was like just two, and actually I think that the DB scheduler is mentioned in Shadlog project, and that's the reason why we have found it. And no reason to choose anything else.
Do you